Okay, let's look at a practice assessment. This one has four functions or graphs here, and we need to find the equations and the domains of each graph. Now we've given possible functions at the bottom of the page, which you'll have in your assessment, and you need to find the name and equation for each graph, the method, how you find the constant, the a, and the domain, relevant domain for each equation. So let's take a look at each kind of graph. Page 2. So we have, well, our parabola is easy to find, so that's, let's find the colour here. Our parabola, we have y equals ax squared, and we know that's a negative parabola because it's upside down. We have a cubic here, a cubic, y equals ax to the power of 3. We have an absolute graph, absolute value graph, y equals a, and then absolute value. And we have this one here, it looks like it's half of a hyperbole graph, y equals a over x. So those are our four graphs, and we'll look at each in. To start off our parabola, we can see that the vertex here has been moved from 0, 0, it's come across 5 and up 2. So I can write that y equals, now we usually have an a, it's become across 5, remember, to the right is a negative 5 squared, and it's gone up 2. So we have to work out how far it's been stretched, or what this constant a is. The easiest way to do that is to pick a point and to put it into your calculator. So let's take a clear point. It's a bit hard down here to see exactly if that's 7, 0 or not. So I'm going to be safer with this point here. Let's take 5, 6, 7, 1. So my x is 7 and my y is 1. So I can put that into here, so y is 1 equals a times a bracket, my x is 7 minus 5 squared plus 2. Now I can work that out by just taking 7 away from 5 is 2, squared is 4, and I have 1 minus 2 on the other side, and I come up with my constant a equals negative 1/4. Another way to save making slip-ups here is to use your calculator on equation solver. I think we've done that before. You can just put this straight into your calculator, use the a on your calculator, and remember, do execute, and you'll find a is a negative 1/4. So my equation is going to be, the function is y equals negative 1/4, and we can see the parabola is negative because it's upside down, x minus 5 squared plus 2. Now the domain, remember, is the x values. So my domain, the x values extend from where x is 2 to where x is 5, 6, 7, 8. So I have 2 and 8, and x is between those or equal to those values. So x is greater than or equal to that, less than or equal to that. So that's my domain. And I can also say x is an element of real numbers. My first graph, let's look at the cubic. My cubic, I know, is y equals a x to the power of 3, and because it's this shaped cubic, the easiest way of finding it, y equals, now some constant, and I can have 3 brackets. Now because this point here is just touching the x-axis, 2 of those brackets are going to be the same. Now I have an x in each of these brackets, sorry I'm squished up here, and I want to make, I know that on the line here we've got x equals -5, and this point here where it cuts the x-axis is x equals 5. So when x is 5, y equals 0. When x is -5, y equals 0. So if x is -5 here, I have to add 5 to make that bracket 0. And I have 2 of those points. And this one over here, when x is 5, to make this bracket 0, I take 5 away. So my equation then for this graph, y equals a x plus 5 squared. I've got 2 of those, and x minus 5. But I need to find my a. Again, I can put it in equation solver. I'm going to find a point that is pretty clear. I can use, doesn't, well, I could use the point, usually the point on here, this is 12.5 by the look of it. So when x is 0, y is 12.5. Again, use equation solver. It will stop you making silly mistakes. But if you're confident, that's fine, just working it out. And my x is 0, so that's going to be 0 plus 5 is 25, times 0 minus 5 is 5. So a equals 12.5 divided by 25 times -5 is -125, I think. Yes. So a equals -1/10, or -0.1. When you're using equation solver, don't forget execute. And so my equation for this cubic is y equals -1/10, or -0.1, x plus 5 squared, and x minus 5. And my domain, my x, here I'll just leave x as an element of the real numbers. We can't really see where it cuts off on the x-axis. This will just continue to be x, can be any real number here.